My name is Callum Sharp from Arup, and our submission for the Environmental Award is about a successful planning application for a design solution that mitigates noise from the High-Speed 2 railway on a tightly constrained site. At this site, a significant degree of noise reduction was needed in a semi-rural environment, meaning that visual intrusion was a key factor. It also had to meet with local authority planning approval, and it was the first noise mitigation on HS2 to successfully achieve this outcome. The project is part of the civil design by Skanska Costain Strabag, or SCS, the main work civil contract currently designing the southern section of what's known as Phase 1 of the HS2 route from London to Birmingham. We're particularly proud of this project as it's an example of where acoustics has been the driving force behind the design, and we've arrived at a solution which satisfies not only the acoustic requirements, but also the needs of structural engineers, landscape architects, local authority, and other stakeholders. So what were we trying to achieve with our design? The High-Speed Rail Act has a schedule which aims to ensure that there's a proportionate level of local planning control. Whilst noise is not material to approvals under this schedule, HS2 have developed planning standards and practices that require them and its contractors to demonstrate how the noise mitigation performs and how noise has been reduced as far as reasonably practicable. This is to provide reassurance to the qualifying authority that the mitigation is appropriate. The West Ruislip section of the HS2 route is close to residential communities. It's also a heavily constrained site alongside the existing Chiltern railway line within a relatively narrow corridor. This means that landscaped earthbunds, which otherwise might have been a more aesthetic option, are not a practicable solution. So, to achieve the project commitments and to provide the necessary reassurance for the planning approval, a high-performing noise barrier solution was required. So how did we arrive at our design? At the initial design stage, we came up with 12 different barrier solutions, all variations in terms of barrier location, height, and shape, with different combinations of designs at either side of the railway to correspond to the differences in potential noise levels at each residential community area. In an optioneering process, these were compared relative to one another, as well as being compared to the design assessed at the environmental statement phase of the project. And we assessed the designs in terms of the acoustic performance, impacts on other environmental disciplines, particularly landscape and visual impact, and cost effectiveness. Safety and practicability were also considered to make sure that all aspects of the railway corridor, such as line side equipment and walkways, could be safely provided within the design. The preferred solution, which was taken forward to engagement with the local authority and included in the planning application, is for high specification cranked noise barriers either side of the track that maximize the barrier performance whilst optimizing the other parameters considered. The design allows the barrier to be very close to the railway to maximize its performance, whilst providing enough trackside access for safety, inspection, and maintenance, and still allowing space for the inclusion of sound-absorbing materials. Conventional noise barriers present a tall vertical face to surrounding communities, which can be visually abrupt, particularly in the context of a rural landscape such as West Ruislip. The upper section of the crank barriers slope inwards, creating a receding visual form that is sympathetic to their surroundings, whilst maximizing acoustic performance by bringing the diffracting edge of the barrier close to the noise source, rather than increasing its height. Being able to reduce the height of the barrier is not only visually beneficial, but reduces the amount of materials, and hence the embedded carbon and costs, used in providing the mitigation. We predict that the improved acoustic performance of the design will result in noise levels at the nearby communities that are lower than those reported in the environmental statement, and which therefore meet the project's overall aims and commitments of taking all practicable steps to minimize noise from the scheme. Having successfully achieved the planning approval milestone, the design is now being progressed and refined using innovative acoustic modeling developed specifically for the application. The calculation approach draws on complex mathematical solutions to create a simplified but robust numerical modeling technique. The model uses a combination of finite element and boundary element analyses to model the propagation of acoustic energy emitted by the individual sources on the train and their interaction with the absorbing elements of the noise barrier. We're modeling the relative benefits of various combinations of quantity and location of sound-absorbing materials so that these can be optimized along the barrier section, providing a potential reduction in the quantity and cost of materials used without adversely affecting its performance. We believe this project is worthy of the environmental award because not only does it provide a novel solution that meets many objectives as well as the required noise reduction, but it was also the first successful planning application for noise mitigation for high-speed 2, setting a precedent for good multidisciplinary design and providing a clear route forward for progressing the many similar applications that will follow along the entire HS2 route corridor. Thank you.